Hello everyone, welcome back to Science Spirit. Today we learn all about sound. Sound is a form of energy that gives us a sensation of hearing. I am speaking, that is I am producing sound and you all are able to hear it. Sound is produced due to vibration, that is if there are no vibrations, no sound will be produced. Vibrations are nothing but the to and fro motion. We all have seen a swing in a park that makes us happy. It goes front, then back, front, then back. This is nothing but the to and fro motion. Sound needs a medium to travel. That is, sound cannot travel in vacuum. From this line, we can conclude that sound travels through particles in a medium. The speed of sound is 340 meters per second, but very slow from light. We all know the speed of light, that is 3 into 10 to the power 8 meter per second. Sound travels fastest in solids, slower in liquids, and slowest in air. Because the particles are tightly packed in solids, lessly tightly packed in liquids, and they freely roam in air, that is gases. Wave is a pattern in which the disturbance/energy travels. The sound travels in the form of waves. The molecular structure of solid is this, liquid is this, and gases is this. The molecular space in solid is very less, and thus sound can travel faster. Sound is mechanical wave, that is, it needs a medium to travel. We already read this. Now let us understand the sources of sound. The first one is a tuning fork. A tuning fork is a U-shaped metallic piece with a stem in the middle. This is the U-shaped metallic piece and this is the stem. They are set into vibrations by striking them mentally on a rubber pad. So whenever we strike these, they vibrate and they produce a sound. These are mainly used in laboratories. Musical instruments. String-based instruments, guitar, sitar, piano, violin, etc. have strings stretched on them. We all have seen a guitar, there are some strings like this, and whenever we strike one of them, they start vibrating and producing a sound. Membrane-based instruments, tabla, dholak, etc. These instruments have stretched membranes which vibrate to produce sound. We have seen a tabla, it looks like this, and this is a membrane. It is a stretched membrane which produces a sound by vibrating. Air column based instruments, flute, shehnai, etc. These instruments have air columns of various lengths and thus produce various music. We all have seen a flute. It looks like this. There are some holes. This helps the air to pass through and produce various music sounds. Now the third one is the human being. Human beings have vocal cords in their voice box. These vocal cords are stretched bands. We can see over here. These are the human vocal cords. They are relaxed when we do not talk and stretched when we talk. When we breathe, the vocal cords become loose and the gap between them increases. When we talk, shout or sing, the cords become tight and hence they vibrate and produce sound. The human voice box is also called larynx. Inside larynx, the vocal cord is like two folds of tissue. You can see over here it looks like a tissue paper and having two folds. One oscillation or one wave or one vibration is one to and fro motion. That is from the mean position to the extreme position, back to the mean position, then to the other extreme and back to mean. Let us understand this by a pendulum. So we can take this as a pendulum. This is the mean position. Then it goes here. This is the extreme position. Then again it goes over here. It comes back to mean position and again it goes to other extreme position. This is called an oscillation. Now let us understand amplitude and wavelength. The maximum distance from the mean position to the extreme is known as amplitude. So here, this is the amplitude. The distance covered by one wave is known as wavelength. So these are the waves and the horizontal distance between them is known as the wavelength. Wavelength is measured in meters and so in amplitude. Wavelength is denoted by this symbol which is known as lambda. Time period. Time period is the time taken for one oscillation. So like if that is going from the mean position to the extreme, then again to mean, and then going to the another extreme and back to mean. It is measured in seconds. Frequency. Frequency is the number of waves produced in 1 second. Frequency has a unit per second or second to the power minus 1, that is 1 by second. Frequency has a special unit called hertz. We write it like this when we denote something, which is 1 by second. Characteristics of sound. Loudness is directly proportional to the square of amplitude. pitch is directly proportional to frequency. That is this. Higher the frequency, higher the pitch. Lower the frequency, lower the pitch. An infant has very high pitch because of the small vocal cords. A woman has higher pitched or shrilled pitch as she has small vocal cord than male vocal cord. Pitch is a characteristic of sound which distinguishes a shrill sound from a flat sound. Loudness is a characteristic of sound that distinguishes a loud sound from a feeble sound. Now let us understand the human hearing range. A human cannot hear below 20 Hz and more than 20,000 Hz. Now let us understand infrasonic and ultrasonic sounds. Infrasonic sounds are the sounds which have a frequency less than 20 Hz. Elephants can hear infrasonic sounds because they have very large ears. Ultrasonic sounds that have a frequency greater than 20,000 Hz. A human can definitely not hear this, and a human can also definitely not hear infrasonic sound, but bats can hear ultrasonic sound also. Now the last topic is reflection of sound and echo. Sound can be reflected by many surfaces. If it gets reflected and reaches us in more than 1/10 of a second, then we can hear it again. This is called echo. In childhood, we all have played. Echo is the distinct sound heard from the reflection from a distinct rigid surface as a hillside. So suppose this is a hillside and I am standing over here. There is a distance of 17 meters, and if I shout, I can hear my sound again and again. These rigid surfaces should be at least 17.2 meters away. Thank you for your cooperation. Have a nice day.